Hi there, this is Abhishek and welcome to this Tableau tutorial video. And today I'm going to talk about something really interesting. So as you are aware, that data science is getting a lot of popularity, and today we will see how you can implement a data science algorithm into Tableau. So what I'm showing you right now here is some group of data sets or data actually into the data set, all these data points, which you can see have been highlighted with blue, red and green color. And this is basically an example of cluster. So you have let's say a data set and you are not much aware about the data set, and you are running an algorithm, the clustering algorithm, to identify the similar groups, the characteristics which has similarity among those groups. So we have like 3 groups, and green is basically indicating that all of these values which are surrounded by surrounded the center of this data set or the data point is actually similar. Same is the case with the blue. As you can see, there is quite a bit of difference in terms of distance, as you can see. So that's basically a base of a clustering algorithm within the Tableau, and the algorithm that they use is k-means clustering. So if you want to know more about the k-means clustering, the distance-based clustering, you can Google it. It's pretty straightforward. Based on the central point, which they call centroid, they basically see within the close proximity what are those values which are coming, and based on that they label it as a one cluster, like in this case red cluster. And so that's how they keep on identifying the new centroid and the new values, and they keep on doing the clustering. So that's about the technicality about how it identifies the center point, and based on the distance it check all the labels, and if it goes beyond the distance it does not identify. So for example, these black points, if you would see, since they are going beyond a certain point of distance, they have not been identified as any of the associated with any of the cluster. So that's much about theory. Let's go into the practical, and before I go, I'll show you the data set. And the data set that I have is the iris data set. It has 4 numerical variables: sepal length, sepal width, petal length and petal width, and these are the species of flowers. If I show you, Setosa, versicolor and virginica. So this data set was created long back, somewhere around sometime in 18th century, and it's basically to study the different types, characteristics which these different species exhibit. So we will get this, and we will just assume that we do not know about these species. We are just having this data set, these 4 variables, and we try to cluster, create 3 clusters since there are 3, but we'll see how we can use the cluster algorithm and create such a cluster that will identify these 3 species. Alright, let's go ahead into the Tableau. Here I have the Tableau open, and what I'll do is click on the text file, and here I am on the desktop and I'm using the iris data. What I'll do is there are 2 ways to get this data set. One is the UCI machine learning library. You can search it in a Google. So it's UCI machine learning library, and there you will get the data set. Even if you search it with the iris data set on the Google, you will very easily get it. Although I can just upload it on a Google Drive and share the link in the description. Okay, so here we are with the sepal length, sepal width, petal length, petal width and species. So what I'll do is I'll just hide this. I don't need this, and I'll move on to the sheet. Okay, here I am on the sheet, and I will create a scatter plot with the sum of this, and what I can do is, for clustering algorithm, I'll just remove this aggregate measure. As soon as I removed it, as you can see, we have this these petal length, petal width, and all these data points related to the species are plotted over here. Now if you want to see the species, what we can do is put a color on it, and we can clearly see that these blue is one type of species like Setosa. Another one is the versicolor, which is having orange, but as you can see near to orange you have some red color also, which is Virginica, and then down up to the top you have Virginica as a species. So what I'll do is I'll just remove this, and with the help of clustering algorithm we will try to see whether this pattern is identified with the clustering algorithm or not. So I'm here on the analytics, and if I go ahead and drop the cluster over here, right, with the petal length and petal width, you will see that it has by default identified the cluster 1, 2, 3 automatically, and cluster 1 is over here, very similar to our original data set. Cluster 2 is over here, again very similar, but if you remember down here or somewhere here we had some red marks. So in this case it has predicted almost accurately, but not 100% accuracy with 100% accuracy. And on top of that you have the red color, which is a cluster 3. So that's very quickly how you can create the clustering algorithm, and this is also called unsupervised algorithm. Why unsupervised? Is because you do not know anything about data. So for example, if we did not have these species, we would have to experiment with the cluster, like 1, 2, 3, how many clusters we really want, and then if it gives us some sort of idea that yeah, these clusters make sense because they represents the similar nature, we would have gone ahead and used it. So that's very quickly about how you can implement the clustering algorithm. Now another interesting piece is, once you have created this, what you can do is you can use this cluster over here in the as a dimension, so that you can use it maybe later in the stage for further analysis. And it's pretty straightforward way. If I just go ahead and drop it over here, it will create based on the petal length and petal width, it is going to give the cluster. So maybe we can say it is species cluster. Now we have this cluster, and as you can see, this paperclip sign, which indicates that it is basically creating a group. So once it is added over here, you have the option of either creating duplicate or even edit the group. So let's go ahead and edit the group, and let's say you want to change the cluster name. So you can click on the cluster name, and I think first was Setosa, second was Virginica, and third one is I don't really remember that. Okay, but idea is that you can rename it, and you can, let's say Setosa, and we will say second one maybe Virginica, and I'll just see what is the third one, Versicolor. Maybe third one is Versicolor. Okay, and with that I'm done. So that's how you can change the groups. So whenever you will get these groups over here, these names will be changed, the cluster names will be changed, and that will be more business friendly name as compared to simply cluster. Now after this, what you can do is you can further experiment, since there is no limitation, or it's simply based on how much you can really think, and you can combine with petal length and sepal length, or petal width and sepal width, and try to see whether you are getting more and more accuracy. The only thing is, I would suggest that do not even try to get 100% of accuracy. First of all, that's not possible. Even after a lot of manipulation, a lot of experiment, if you get it, that will lead to one of the problem in data science, which is called overfitting. That means you are overly manipulating, overly simplifying the data, which may work well when you have some seen data or you are aware about it, but on unseen data it will never gonna work. I would say not never, but most of the time it will not gonna work. Okay, so that's about cluster. What you can do is it is also very important that you identify that how many values it has calculated right and wrong. So what you can do is create a calculated field and basically say maybe accuracy. Yeah, that's what they say in data science, accuracy. and what it is basically species cluster is equals to species. Okay, and what I can do is I can create another sheet, and I will just say accuracy on the column, so it has false, but it should have shown us true as well. So let me quickly go back and check. Edit species cluster, okay, equals to species, and okay. And what I'll do is just one quick check is I'll just create one sheet. I will say Peter length, Peter width. I will remove the aggregate measure. I'm sorry about that. Peter width. And then based on species, I'll put it on color. Setosa, versicolor, virginica. And that's our actual data. And here, if I go ahead and remove the cluster, or simply remove it over here and put it species cluster over here, and Setosa, virginica, versicolor, I'm just checking the ordering. So Setosa, versicolor, I think that's, we should have the same naming convention, otherwise since it is equals to, it is checking whether it is true or false. So in small case, Setosa, versicolor and virginica. And I will just go ahead in the cluster, edit the group, rename. So first one is Setosa, which is in small. Second one is virginica, and I need to check, I'll check once again, and versicolor, V-E-R-I-S-C-O-L, okay. Setosa, virginica, versicolor, Setosa, okay. I just need to have versicolor as the second one. So that's, sometimes you may not get the correct output, and you need to really see whether values are properly, you know, mentioned over here. So I will name it to versicolor, otherwise you will get more false than right, and which is not right. Click OK, and let's see this. I'll just remove that. Edit species cluster equals to species. I will come here. Now we have true and false both, so that's good. And to basically get the count, what we need to do is bring another, you know, field over here, which is nothing but number of records. Okay, so we have 52 is false and 90 is true. Again, doesn't seem to me something which is absolutely correct. Maybe I'm just messing up with the, you know, the naming over here. So if I go like VIR, right? So this will create an issue. What I'm doing is VER, I'm saying, however it is VIRGINICA, VIR. So what I'll do is I'll go down and copy this so that I'm not messing up more with that. Edit group, come here and rename. No, not the one, this one, rename. So we are good over here. And then versicolor, I'll just check once more. I'll go up and VERSICOL. Yeah, I'm good over here. So I'll click OK. As soon as I click OK, let me see the count. So now you can see, now it is as per my expectation that only 6 incorrect values which it has classified or clustered wrong. However, true is 144. What we can do is create a bar chart. So with that, and it should have come. Our chart. Okay. So with that, you can see, or you can visualize, give the visualization back to your users about the accuracy part. How much is the accuracy? And third thing is you can combine all of this into a cool dashboard. So let's go ahead and create that to complete this entire information. So new dashboard. We are bringing the sheet 1, which is our so I will just remove 1. Alright. Okay. So we'll give sheet 1 name as ML, which is machine learning cluster, real values, and accuracy. Okay. And here I'm coming. So this is the ML cluster, clearly indicating this is the real value, and as you can see here, in case of this orange and this is red, so this is misclassification. After that, we can produce a plot of accuracy as well, and we can see that we have more true number as compared to false. So there is a reason that you can trust our algorithm. So that's about it. But as I said, it's just one single way or one way of thinking about it. There are a number of ways by which you can think, and you can further improve it via dashboard or something. So that's the first video that I have. I will show you a couple of more examples in coming days related to clustering, so that you will get a better idea and more data to play with. Hey guys, welcome to the Tableau tutorial, and here in this video I will talk about the clustering. So in my previous video I have talked about what is clustering, and we took the iris data to create a cluster to identify the 3 different species of flower. And here in this video I am just showing you one other example that will basically help you get more understanding, and probably you will be able to see the clustering from a different angle about how you can apply it. So what I'm going to use is the Titanic data. It's one of the very famous machine learning data set, the Titanic, and I will paste the link. I will upload this on a Google Drive and paste the link so that you can also download it. And what it basically has, some of the values related to passenger ID, ticket class, what class is, survived. That's basically your target variable, is what we usually say in machine learning, is whether somebody survived or not. So what we will going to do is by looking at the gender, maybe by age, maybe by their say for example ticket class. Based on all of these features that you have in this data set, we will try to see and try to create a cluster to understand whether survived or not survived shows some sort of common characteristics, or whether our clustering algorithm identifies who really survived and who did not survive based on the different features that we have. So here we have the Titanic data, and now let's go into the sheet. So the first thing or the first 2 variables that we will going to take here is, let's say maybe age and ticket class, for example. So what can we do is age and ticket class, and quickly we will do is within the analysis we will remove aggregate measure. So here we have the ticket class, class 1, class 2, class 3, right? And this is the various ages which are traveling in these different classes. Alright, so once you have it, what we can do is go into analytics, and we have the cluster. I will just bring the cluster over here and put it here, and here we have age, ticket class, okay, as the 2 variables which it has the algorithm has taken into consideration for creating the clusters. Now what it is doing is it is saying cluster 1, cluster 2, cluster 3 and not clustered, but and it's basically automatic identification of cluster. As you can see, number of cluster is automatic over here, but since we know that there is only 2, which is either somebody survived or not survived, what we'll do is just press 2 and hit enter. Now we have cluster 1, cluster 2 and not clustered. So probably not clustered is something like for the nulls, so no issues on that. I'll just close this, and cluster 1 and cluster 2 are showing some sort of properties. So what I'll do is I will just go into this and I will take the survive on the detail, okay, and I will try to see survived is 1 here in this case. So as you can see, maybe survived is related to the cluster 2. So in most of these cases, if you see, survive is 1, and here in most cases survived is either 1 or 0, right? So what we'll do is let's try to visually compare it, and let's try to create a copy and paste. So here we are, and let's remove the cluster. Quick remove, and let's put survive on color. And here, as you can see, basically 0 and 1 is your cluster, and there are some of the higher ages which were not, which were not survived, and some of the children's and middle age. But as you can see, there are a lot of people from class 1 and class 2 as compared to the class 3 who got survived. So right now our algorithm is not clearly showing that. So what we can do is, let's go into the cluster, click on the added cluster, and along with the age and ticket class, what we can do is we can add the survived as well. And now let's see it. Okay, now if you see, we have a good representation in terms of who survived and who did not survive. For example, this saying that this person has survived and the ticket class is 3, as compared to this person is not survived and the ticket class was 3, right? Similarly, here in this case, seems like all of these are children's who really got survived, but all these middle-aged guys, were not able to survive much. Like in this case, children as well as some of the middle age, as well as here in case of the old age people who got survived. So let's try to compare it with the sheet 2 that we have. So here in case, let's say these 2 is indicating not survived and this is indicating is survived, and if I go, you will see that a similar sort of representation. Similarly in this case, all of these children got survived, and let's see the actual. Yeah, even in the actual you will see that all of these guys were really survived. And here in this case, these are the 2 interesting observations from the actual data. Here we are not using any clustering, as you can see, and it is saying that these 2 guys have survived. And let's see it over here and see these 2 guys clearly indicating in a different cluster, and it is basically saying that they have been survived. So we can get some confidence based on this visual representation analysis. Now in the last video, I have shown you how you can really take the cluster, create a dimension out of it, and then create a true-false values based on after comparing it with the here in this case survived. So how you can do that? You can visit my previous video, the very first video of Tableau machine learning, and see it how I have done it, so that you can do the exercise over here. Now let's try to see the similar sort of analysis from a different angle or from a different variable. So what I'll do is I'll add one more sheet over here, and let's now take for example age, and let's take gender, and analysis, aggregate measures, we have removed it. So let's keep it actual, and I'll just put the color. So this is our color, and 0 is indicating the not survived, but we do not want range, we just want proper color. So I'll just go in this and click on edit color, and I just want 2, right? And maybe what I can do is I can use a better one like this, not diverging. So this is indicating 0, this is blue is indicating survived. So we can clearly see this. So now we have a clear idea about how my actual values are looking. So what I'll do is I can create a copy and paste it. And now let's try to shift it on the right. And now let's, I will just remove it, put it on detail, and add the clustering. I'll add the cluster by dragging it over here. So now we have gender, age, and survived, right? And by default it is identifying 4 cluster based on its automatic algorithm, but we know that we just need 2 cluster. All right, and cluster 1, cluster 2. If you want, you can remove that, but say for example there is nothing but probably the nulls. So what I can do is I can go to the clusters and click on the not the sort filter. Click on the filter and remove this. So I have a clear representation. Now if you see on the female, as we can see, are more survivors. So let's see if that is the same case on the actual data. So female 1, and as you can see it's a lot of females which it has the actual data is saying that they have been survived, and as compared to all of these males. So only in cases like children's we are able to see it, and these guys who were pretty young, but as you are moving on the age 55 and beyond that, they did not survive. So let's see what clustering is doing. So in clustering, some of the values it is identifying in case of children that they have not survived, which I think is a misclassification or missing pieces. But here in cases, it is specifying or identifying that they have not survived, and here also. So in case of age and gender, we are seeing that clustering is not very effective, and giving us more false values when we compare it with the age and ticket class. So that's the kind of experiment we really need to do to identify what variables are really making sense. And based on that, say for example in added cluster we have age, gender, maybe let's say having a ticket class makes sense. That's what we have identified. So what I'll do is add a class and try to see whether it improves the result or not. So this way you can experiment with the data and experiment with your variables, create a different views, and finally to consolidate the views you can create either a dashboard or maybe a story to basically drag your sheets and try to create a story that based on your observations, what are the variables that are really contributing to identify the good clusters and what are those clusters. So that's pretty much about it. I will try to gather more and more examples for you so that you can do more and more practice. But I will try to create more videos from forecasting as well, which is the inbuilt into the Tableau. So stay tuned for that. Hi there. In this video, I will talk about the Tableau internal machine algorithm linear regression. And as you can see, the objective of linear regression is to fit the best line by minimizing the errors. So here we have one example where we have age on x-axis and we have salary on y-axis, and as you can see this is basically indicating that age is increasing, and if you see the salary, the y-axis, you will see that salary is also increasing. So that's a simple example I wanted to show you to give you an example of linear regression. So idea behind linear regression, or the assumption, is that the two variables of our interest for which we want to do the prediction, they should be linearly correlated. Now in this case you can see they are positively linearly correlated, there may be scenarios where they are negatively linearly correlated. So if that assumption is met, then we can go ahead and fit the linear regression. So to fit the linear regression, we can use Tableau internal machine learning algorithm. And so what I'll do is I'll go to Tableau. Here, let me open the Tableau, and what I have is as a sample data set is this Boston housing data set. What it has is the price information in thousands of dollars for the different apartments based on the these parameters like the crime rate in that locality, the number of rooms per dwelling, the age group in that locality, and tax and PT ratio. So different parameters that we have. So what our objective is to predict the price based on these different parameters. So what we can do is say average number of rooms are pretty good idea about what the price should be. Generally we look at, whenever we go and look for any apartment, we see number of rooms and then see whether the rent or the price of the entire apartment making sense or not. So we will take these two variables and see whether we can fit the linear regression. Alright, so here I have the Tableau. I will click on the text file and I will put the Boston dataset over here, and this is the Boston dataset, the same one which I showed you over here. Once it is there, I will go into the sheet, and once I am here in the sheet, what I can do is I can take the RM, which is average number of rooms per dwelling, so I can put it in the columns. So we don't need the sum, but what we need is the dimension, and then what we have is the price. I will put the price here, and what I'll do is change the visualization to the linear. And if you see, as the average number of rooms are increasing, the prices are fluctuating and giving us an indication that it is increasing linearly. So to fit the linear regression over here, we need to go into Analytics tab, and here we have the trend line, which will basically fit these data points by minimizing the error. So I will just take it and put it over here on the linear. As you can see, you have other algorithms like logarithmic, exponential, polynomial. So what I'll do is I will put it on linear for now. So now this linear regression line is fit, and if I hover my mouse over to the line, you will see this equation which saying price is equals to 9.15176 multiplied with RM. That means as the number of rooms are increasing, it will be multiplied with the 9 as it has identified it as a slope of the line, plus minus 32.0593 is basically an intercept, which is indicating if average number of rooms are constant, then whether the price will continuously increase or decrease. So in this case, it is saying it is relatively decreasing. So with the help of this equation, you can basically find the based on the number of rooms, you can find the price. Then also you have R squared value, which is saying 0.29. That means with the help of this average number of rooms variable, you can only explain 30% of this data. Now this value is not good, because R square value, which is somewhere around 80, 85% or 90%, that means whatever error that it has identified, it can explain that error at least by 80%. Right now it is explaining the error only by 29.5%. So our model is better, or the linear regression model is better, if R square is value is high, which indicates that it can explain the error in this with the help of this model. And the p-value is indicating that whether this variable is significant or not. So in this case, the value is less than 0.05, and that's the threshold you really need to remember, that if the value is less than 0.05, then you will accept this, otherwise you will reject this. After fitting the trend line, what I can do is add the reference band to get a confidence interval, because whenever we are predicting, giving just the actual prediction value does not help, because there is an error. So what we really need to do, provide the upper boundary and lower boundary about how much it can variate. So what I can do is right click over here and click on the edit trend line, and here I have the show confidence bands, and I'll click OK. Apart from these confidence bands, what you can do is, when you are here on the line, you can right click and you can even click on describe trend line, and this will basically give you the equation, the p-value of overall model, and then the RM variable, the intercept, and then again the p-value for both these one. You can even copy and paste it in some presentation if you want. The last piece is describing the trend model, and here you will see the different labels like model formula, number of model observation, fitted observation, number of filtered observation, model degrees of freedom, all of those statistical parameters of your need, as well as the same similar type of statistic we saw in the previous screen, which was a bit small, but here it's pretty extended, like sum of squared error, which is also called explained error, the mean squared error, which basically helps in calculating whether this model is performing good or not. That means the average error in the model. Then by adding or removing variables, you will see the value will go up or down. So lower the value will be, the better the model is. That's kind of a nutshell the idea is. So you can also, if you are really interested in the statistic, then you can also use the statistic as part of your presentation and put it. So that's pretty much about it, about how you can create a straightforward linear regression model into the Tableau, and fit a line, get a formula, as well as the confidence band, just to see at a 95 degrees of 95% degrees confidence interval what the band will be. But as you could see, this is not where this process ends, because this is a pretty exploratory process where we look at different variables. So far we have looked at only the RM, but in the future videos I will show you how we can even look at multiple variables, and on that statistic, the R squared, how we can really increase it to a respectable level so that you are able to get the better model with the lower mean squared error. So those are the two parameters. R squared should be good, somewhere around 80 or 90%, and the mean squared error, MSE, should be less for your model, and that can be compared by adding more variables. Hey guys, this is Abhishek, and in this video I will give you one exercise which you need to complete, and if you find any problem, then you can either comment me or simply email me. But it is very similar to what we have done in the previous video, where we have looked at the linear regression, and we looked at the example of Boston housing data set. So let me go back to Tableau, and you see that we have taken the price and rooms, average rooms per dwelling, and created a linear regression model. Now what I want is you create another sheet over here, take crime rate and price, and create a model. So this will give you an idea what could be the price in case the crime is higher or lower. Similarly, once you have created that, I would really encourage you to experiment with the other variables, which is DIS, CHAS, or tax, and all of those ones. So hope you will be able to easily do that, but as I mentioned, in case if you find any issue, just comment. Hey guys, welcome to the solution video, And if you remember, in my previous video I've asked you to create the linear regression model between the price and crime rate. So let's go ahead and first of all put the price over here and crime rate here on the column, and in the analysis say don't aggregate the measure. And as you can see, the price is decreasing when the crime rate is higher. So what we need to do is to create linear regression is go into analytics tab and find this trend line and say linear. And as you can see, we have the negative linear regression, where it is saying that in 1000 price is declining by 0.412 or 0.413 in round figure when you multiply it with the crime rate plus 24.0162. So using this equation, you can place the value of CRIM, which is crime rate, and predict when the crime rate is going up or down, what should be the expected value of the house. So that's quickly how you can create it. Also, if I right click and go into the edit trend line and show the confidence band, I will see that confidence band is pretty higher in case of a crime rate when we compare it with the average number of rooms per dwelling. So that's how you can very easily create linear regression, and hope you found the solution useful. And I would, like I mentioned in the previous video, I really encourage you to now look at other variables, create different sheets, give a proper name to this sheet, like crime versus price, like this. So CRIME, crime versus price. Similarly, create another one and look at DIS versus price, and try to see when you are going here on this line, you are getting three value: price, R squared, and P value, and try to document the value of R square and see where you are getting the highest R square. Once you get the highest R square, that means that's the most useful variable. So 0.14 we are getting over here, and in case of average number of rooms we are getting 0.48. So 0.48 is definitely better. So that's a better variable than the crime to predict the house prices. So I would really like you experiment with the other variables against the price and find out what you observe. Hey guys, this is Abhishek, and in this video I will talk about how you can create a correlation matrix like this. So in the previous video, if you have seen, I have talked about the linear regression, and one of the very first thing that we do before we move ahead and create linear regression is to see how many variables are correlating well with the dependent variable. So our dependent variable was the price. We were using the Boston housing data set, where we wanted to predict the price based on the different variables like the average age of the people living there, the crime rate, and number of rooms per dwelling. And this basically gives a good idea about whether there is a positive or a negative correlation. So for example, price and crime rate, and as you can see, the crime rate is basically going up, then what's the price is. Similarly, over here in the DIS, you can see the correlation between the price and the DIS, like in this case. So as you can see, the DIS is going up, the price is also going up. In case of age, as the age is increasing, and the correlation with the DIS is that it is decreasing. But in case of price over here, it's bit negative, but not very much. As you can see, it's relatively straight line, but going a little bit downwards at the end. But as you can see, you have this price, crime rate, since they are same, like price over here and price over here. That's why a positive correlation you will find in all of these variables which are there at the center. So it's pretty easy. If you are an experienced Tableau programmer or a user, you can see that very easily I have created this. But if you don't know, then let me create it for you. So here I've created a new sheet, and what I'm doing is I'm just adding a price and price. What I need is within the analysis, I don't want to aggregate these measures, and as you can see, now I get this information. Now let's say I want to take age. Now here the age is coming. Similarly, I will take age over here. So I will keep on going crime rate, and then the crime rate, and maybe, you know, indus, the different variables that are there. Similarly, number of rooms, let's say room, let me do it again, and maybe tax, average tax in that locality, whether there is any correlation. And what I'll do is, since it has become a bit squeezed, I will change from standard width to fit width, and now my correlation matrix is ready, similar to what I created over here. So this way, very easily and intuitively, you can decide which variable to take. So for example, this RM with the crime rate is not at all correlating, but with the price, you can see that as the price is increasing, the number of rooms is also increasing. So that makes sense that more number of rooms, the more will be the price. And with the crime, lesser the crime, higher the price. So, and when the crime is higher, price is lower. So that makes sense. But in case of, for example, if I see price with this, or the indus, you know, it's pretty straightforward. I mean, I do not find any correlation, because when the price is high, you will find the higher value as well as lower value for indus smaller values. But when the indus smaller values are becoming higher, then there is no significant effect on the price. Same is the case with tax, as you can see over here. So this way you can you can visualize the correlation matrix and see your variables in action, and that's a chart which will work as an explanation that if you have chosen some variables, why you have chosen that. And once you will show your user this chart, they will be pretty confident, okay, they are seeing correlation, whether they are going above together or going down together. Based on that, they will make a good impact in your linear regression model. Similarly, other models, because correlation is not only related to linear regression but other regression models as well. Hi guys, welcome to the next video. And in this video, I will talk about how you can integrate Tableau with R. So to integrate Tableau with R, we need RServe package, which is present in R, to establish the connection between R and Tableau. And when you are connected with Tableau, Tableau basically passes the code with the script methods, and then R processes that data with the live connection that we established with the help of RServe package and return the output. So first of all, let's see how we can establish a connection, and then we will look at the script method. Alright, so if I come back and come over here in this R, so one of the function I showed you in the last video, which is library and RServe, that's one way, and I'll just remove that. Another thing is you can go into the packages and say load package, which is again another way by which you can load a package, and we will find a package which is RServe and click OK. So it is giving us just a warning message which we can ignore, that RServe was built under version this, but we may have a different version altogether, like 3.2.5, but version we are running is the older version. So if we upgrade that, then we will not get this warning message. Okay, once you have loaded it, you need to run this function which is RServe by simply writing RServe, press enter, and it is saying that starting RServe and rserve.exe. That means the service RServe service is started, and now we can go to the Tableau and create the connection. Alright, so here we are in the Tableau, the previous file that we have I have opened. And what I can do is I'll just close this for a moment. I don't want to save it. I'll open a new Tableau workbook, and let's say I want to use some of the saved data source, which you will also get once you download it, and go to the help and click on setting and performance, and come here, manage external service connection. Once we are here, the server should be localhost because we are running this server locally, and then the port should be 6311. You don't have to pass any username and password, and simply click on test connection. It will say successfully connected to the R service. Click OK and click OK over here. Once you are there, then you can start passing on the argument. So what I can do is let me show you some of the syntax first. So if I come back to my presentation, and let me go into the present mode and come back here, which is introduction of Tableau in R and syntax overview. So it has 4 different types of function. One of the function we will going to use is the script underscore real, and what it indicates that it returns the real value. Similarly, you have script underscore bool, which returns boolean value, which is true and false. So in this script, what you write is the script underscore real function surrounded by double quotes until here. So in this double quotes, you will pass the R arguments, or the arguments that you want to pass to the R. So that will be passed in the manner of .arg1. This .arg1 is connected to sum of sales, and after that another comma, you have sum of profit, which is connected to .arg2. Similarly, if you had 3 different or 4 different one, then you must be having the arg3, arg4, arg5, depends on how complex your calculation is. So by this you can understand that within this double quotation you will pass all the R code, and to get the data which is present in our data source, we will use the arg method. Argument 1, argument 2. Argument 1 will be connected to the first expression. Argument 2 will be connected to the second expression. Similarly, if there is argument 3, argument 4, they will be connected to their respective third and fourth aggregation function. So that's quickly about it, and let me show you this thing into the Tableau. So if I close this for now, presentation mode, and come back to the Tableau, what I'll do is I'll go into analysis and go into the create calculated field, and let me just write rfunc, and if I write, like I mentioned, it has 4 different ones. So script underscore bool returns boolean value, script underscore integer return integer value, script underscore real returns a real value, and script underscore str returns the string value. So let's go to the script underscore real, and what I can do is like I mentioned, I will write dot arg1 plus dot arg2. That's the one, and after this what I can write is comma sum of sales, because I have sales over here in this measure, comma sum of profit. Alright, the calculation is valid. What we can write is our result to make it more meaningful, and click apply and OK. So now we have R underscore result. What I can do is I can, let's say, take the state over here in the rows, and I can take R results over here. It will take a couple of seconds based on the processing R is doing, but now you have the addition of sales plus profit. Now if you want, you can have the sales over here beside to this. Maybe I'll just put it over here, and probably on the text. So now you get sales over here and the profit, and if I want, I can also get the profit, say for example on the text. So you got three different values: sales, the profit, and the result. And as you can see, for Alabama, sales is 19,511 and profit is 5,787, but the R result is giving you the total, which is 25297. So this is just a basic, very basic explanation about how you can do the R expression. So if I come here on this pill, click on the drop down which is present at the end and go to edit, I can come back to my expression, and if I want, I can use multiply or I can use divide or any other one based on which I want to process. But this functionality is already present in Tableau, but only thing I want to show you is how argument 1 and argument 2 is taking the value from your expression, going back to the R and processing the result, and then coming back and returning the value to this function. So that's quickly about R related function, about how it processes the data and what are the basic parameters that you need to pass. So that's pretty much about it for this video, and I will meet you in the new video, the new topic. Hi there. In this video I will cover rest of the two plots, which is correlation matrix and box plot chart. Alright, so if I come back here in the Tableau, these are the two charts, the histogram and the box plot. That is what we covered. Now let's come back to the correlation matrix. So correlation matrix is nothing but the extension of the scatter chart that you showed, but since it has a lot of different variables, the visualization becomes easy to understand whether variables are linearly correlated, positive or negative, or is there any sort of relationship present apart from linear relationship into the variable. So what I can do is I can simply select, let's say, profit and profit over here, and then sales and sales. As you can see, I'm selecting all of these same variable in both rows and columns, sum of quantity and like now it has created a matrix kind of a structure. So we have quantity and profit, metric, we have sales profit metric, and then we have profit metric. Similarly, we have sales metric, sales quantity metric, and similarly profit sales, and profit quantity. So this is a simple representation of correlation, but correlation matrix, but it's really not in the form because it has a proper scatter chart. So like I suggested in the previous video, we go into the analysis and uncheck this aggregate measures, and now you can see it very meaningful that first of all, this particular section will always be positively correlated. Why? Well, pretty much we have already guessed it, but if not, the profit is, we are checking profit with profit, so it has to be linearly correlated. Similarly, sales we are checking with sales, quantity we are checking with quantity. So since both and y-axis is same, that's why they are linearly upward correlated. But if we see sales and profit, we see some sort of a positive trend, both on a little bit on the positive side and on the negative side. But if I see profit with quantity, it is not showing any sort of trend. It is showing us straight growth, not upward or downward, but a straight growth. So what it is indicating that irrespective of what the quantity is, the profit is not changing much. So this way, if you have other different variables, if for example even the discount, say for example discount here and discount here, and what I'll do is from standard to fit width, and you can clearly see whether there is any sort of relationship. So discount is also not showing any signs, but it is indicating that on 0% discount is high, followed by 20% discount, but in case of 60% discount with the sales is really high over here. So not a positive, but a little bit of linear trend, not so linear trend what it is showing, but it's kind of a very intuitive way by which you can really analyze. So for example, quantity and sales, we see a lot of quantity over here, but when the sales is increasing, the quantity is becoming less. So maybe it's like a little bit linearly downward, that for higher value sale the quantity is less, because maybe that's what. So for example, we are purchasing a higher electronic good, then obviously we will purchase just one quantity, but here in this case it is like 5 different quantities which have been purchased. So it shows a little bit of near negative linear correlation, and where that is what it is expected. And in that way you can explore other relationships between the variables by plotting like this and creating the scatter plot metric. Now let's go ahead and create the last chart, which is box plot. So what I'll do is I'll select the profit and go into the show me, and here I am not getting the, so it has 0 or more dimension, 1 or more measure. So let me select probably sales quantity. So in case of quantity it is showing me, and if it is not showing you, then what you can do is, like in this case of profit or in case of sales, what it basically looks at the aggregate measures. Once you go into the analysis and remove the aggregate measure, that's what I just tried to do, and by that this particular option will be enabled. So in sales I've just created, so this is my scatter plot, and I can even select one dimension to better represent it, for example region. So these are my different scatter plot. It's not properly plotted because there are a lot of outliers, a lot of values which are going beyond. So what I can do is remove this and come back to profit and select the scatter plot. So again, not a very meaningful, but what I can do is, not even with the slice it will work. I can try and change it, maybe let's say discount, to get a proper figure. And yeah, in case of discount you can see it is properly coming, and what it is having is this shaded area. This particular value is basically median, and this is upper whisker and lower whisker. So what it basically, upper boundary or lower boundary, and this is whisker. So what it basically has, as you can see, upper whisker, 60% of values are coming in the upper whisker, upper hinge, median, lower hinge, and lower whisker, and any value which is above the upper whisker is basically treated as the outlier. So what you can see is the distribution of data. So for example, in case of central, there are comparatively higher discount when you come to the east, west, or south, which is pretty consistent. So that's the the interpretation that you can get. Also there are some outliers both in all of these different cases, which are these. It's up to you whether you want to include the outliers in your analysis or not. Sometimes you exclude it because it influences it, well, or sometimes you do the treatment, probably make it under a certain value or average, or based on what your analysis is saying. But the idea is that you get this analysis to really understand how your data distribution is, and now it is clearly indicating that in central we are giving comparatively higher discount than any other one, and we can then look into this treatment. And but what we know is the central value will going to inflate whenever we are doing any data modeling or statistical modeling. So that's about the box and plot and correlation metrics to visualize and get the idea from the data. And I will meet you in the new video, the new topic. Hi guys, welcome to the next video. And in this video, I will show you how you can do the descriptive analytics in Tableau. So descriptive analytics is a very important step before you actually do or implement the machine learning task. So in machine learning, what you do is you create a model by selecting a variable But it is very important to understand for you whether a variable is significant or not by visualizing it. And we have here 4 different visualization techniques, which is histogram, scatter chart, correlation matrix, and box plot chart to really analyze the data. So what I'll do is I'll divide this video into 2 parts. First, we'll look at the histogram and scatter chart, and then we will look at correlation matrix and box plot chart. Alright, so let's go to Tableau. Here I am on a Tableau, and in this Tableau what I have is the sales field, the quantity, and the profit and discount, all of those different fields. And in the show me, here we have the histogram, and it requires only one measure, as you can see down there, that for a histogram you need to have one measure. So what I'll do is I'll select the quantity, for example, and come here and click it over here, and here I have the histogram. And as you can see, wherever the quantity is between this value and 2, so between 0 and between 2 and 3.5, so 1.5 and 3.5, the quantity is high. That means this is the quantity which is being ordered a lot. So on the y-axis you have count of quantity, on the x-axis you have bins, the actual value of the quantity. So 0 to 1 quantity, 1 to 2, 2 to 3. So this is basically a way by which you can interpret a histogram. Also, you have a way by which you can change the bins. So if you come over here on the dimension, this bin will be by default created for you, and you can click on this pill and click on edit. Once you edit it, you will find the size of the bin. So what you can do is you can specify the bin. Let's say I want to specify 2, and click OK. And if you will see, now it is 0 to 2, 2 to 4, 4 to 6, 6 to 8, all of this. So between 2 to 4, my value is higher. Similarly, if I go back and click on edit, I can keep on changing the value. Also, it has a way by which you can dynamically select the value from the front end and create it. Also, you can look at the different fields like profit bin size, like top customers, to create a bin. But for now, we will go it manually and see this thing in action. If I want, I can change it even to 5 and click OK, and this is how my chart will be converted. So it's a matter of how many bins that you need to create. What I suggest is basically start with at least based on your data. Since it is quantity, the value is somewhere around, maximum value as you can see is 15. I think having a bin size of 1.5 to 2 or maybe x maximum 3 makes sense. But there are different other types of data sets, and it can have value even in thousands. So the bin size will by default increase like 100 or maybe 200, who knows. So it's kind of an experiment that you need to do. And once you become an experienced with the data and with the histogram, this things by default comes to you after just looking at the distribution of data at the default size. So you can start with the default size, which was suggested by Tableau, and then move ahead. Now, what I'll do is I can create scatter plot, not scatter plot. I think if I go back and I want to create the scatter chart. Okay, so here I have another sheet 3. I just clicked on this. So what I can do is I can take sales on rows and maybe quantity over here, and I can see just one circle. So this is a form of a scatter chart, but not really a scatter chart because there are thousands of data points. So what has really happened over here, that it has been aggregated, and that's why you are just seeing the one. So what we can go do is go into the analysis and uncheck this aggregate measure, and now you can see the different quantities. And as expected, the 2 or 3 or 4 quantities are being the highest, whereas I can see that over here there is one outlier over here. Similarly on quantity 6, this is the one outlier. So in case of outlier also, this is a great analysis to do. So another thing I can explore is I can just remove the quantity and I will select profit, and now you can see the negative and positive profit about what is happening. So if you want, even you can select and try to see what is going on over here, and only this part will be selected. You can press escape to come back to a normal stage. So like this you can keep experimenting. I have removed the profit, but I want to now see it from a discount perspective. Here are my discounts: 0%, 10%, 20%. Here in case of 50% discount, what is this value? I can simply select this and get the idea about it. So this is a way by which you can create a scatter plot matrix and get more idea about the variables and how they are influencing your analysis. So that you can do on all of the different numeric variables that you will have and get the idea about it. So that's pretty much all I have for you in this video, and in the next video I will cover rest of the two topics. Hi guys, welcome to the next video, and in this video I will talk about the Tableau's internal machine learning algorithm. So one of the very first algorithm we will see is the clustering algorithm, and as it is mentioned over here, it is an unsupervised algorithm where we are not sure about whether data has any patterns, and by using the clustering algorithms we try to figure out cluster or groups that has similar characteristics. So what I'm showing you right now here is some group of data sets, or data actually into the data set, all these data points which you can see have been highlighted with blue, red and green color, and this is basically an example of cluster. So you have let's say a data set and you are not much aware about the data set, and you are running an algorithm, the clustering algorithm, to identify the similar groups, the characteristics which has similarity among those groups. So we have like 3 groups, and green is basically indicating that all of these values which are surrounded by surrounded the center of this data set or the data point is actually similar. Same is the case with the blue. As you can see, there is quite a bit of difference in terms of distance, as you can see. So that's basically a base of a clustering algorithm within the Tableau, and the algorithm that they use is k-means clustering. So if you want to know more about the k-means clustering, the distance-based clustering, you can Google it. It's pretty straightforward. Based on the central point, which they call centroid, they basically see within the close proximity what are those values which are coming, and based on that they label it as a one cluster, like in this case red cluster. And so that's how they keep on identifying the new centroid and the new values, and they keep on doing the clustering. So that's about the technicality about how it identifies the center point, and based on the distance it check all the labels, and if it goes beyond the distance it does not identify. So for example, these black points, if you would see, since they are going beyond a certain point of distance, they have not been identified as any of the associated with any of the cluster. So that's much about theory. Let's go into the practical, and before I go, I'll show you the data set. And the data set that I have is the iris data set. It has 4 numerical variables: sepal length, sepal width, petal length and petal width, and these are the species of flowers. If I show you, Setosa, versicolor and virginica. So this data set was created long back, somewhere around sometime in 18th century, and it's basically to study the different types, characteristics which these different species exhibit. So we will get this, and we will just assume that we do not know about these species. We are just having this data set, these 4 variables, and we try to cluster, create 3 clusters since there are 3, but we'll see how we can use the cluster algorithm and create such a cluster that will identify these 3 species. Alright, let's go ahead into the Tableau. Here I have the Tableau open, and what I'll do is click on the text file, and here I am on the desktop and I'm using the iris data. What I'll do is There are two ways to get this data set. One is the UCI machine learning library. You can search it in a Google. So it's UCI machine learning library, and there you will get the data set. Even if you search it with the Iris data set on the Google, you will very easily get it. Although I can just upload it on a Google Drive and share the link in the description. Okay, so here we are with the sepal length, sepal width, petal length, petal width, and species. So what I'll do is I'll just hide this. I don't need this, and I'll move on to the sheet. Okay, here I am on the sheet, and I will create a scatter plot with the sum of this, and what I can do is, for clustering algorithm, I'll just remove this aggregate measure. As soon as I removed it, as you can see, we have this these petal length, petal width, and all these data points related to the species are plotted over here. Now if you want to see the species, what we can do is put a color on it, and we can clearly see that these blue is one type of species like Setosa. Another one is the versicolor, which is having orange, but as you can see near to orange you have some red color also, which is Virginica, and then down up to the top you have Virginica as a species. So what I'll do is I'll just remove this, and with the help of clustering algorithm we will try to see whether this pattern is identified with the clustering algorithm or not. So I'm here on the analytics, and if I go ahead and drop the cluster over here, right, with the petal length and petal width, you will see that it has by default identified the cluster 1, 2, 3 automatically, and cluster 1 is over here, very similar to our original data set. Cluster 2 is over here, again very similar, but if you remember down here or somewhere here we had some red marks. So in this case it has predicted almost accurately, but not 100% accuracy with 100% accuracy. And on top of that you have the red color, which is a cluster 3. So that's very quickly how you can create the clustering algorithm, and this is also called unsupervised algorithm. Why unsupervised? Is because you do not know anything about data. So for example, if we did not have these species, we would have to experiment with the cluster, like 1, 2, 3, how many clusters we really want, and then if it gives us some sort of idea that yeah, these clusters make sense because they represents the similar nature, we would have gone ahead and used it. So that's very quickly about how you can implement the clustering algorithm. Now another interesting piece is, once you have created this, what you can do is you can use this cluster over here in the as a dimension, so that you can use it maybe later in the stage for further analysis. That's pretty straightforward way. If I just go ahead and drop it over here, it will create based on the petal length and petal width, it is going to give the cluster. So maybe we can say it is species cluster. Now we have this cluster, and as you can see this paperclip sign, which indicates that it is basically creating a group. So once it is added over here, you have the option of either creating duplicate or even edit the group. So let's go ahead and edit the group, and let's say you want to change the cluster name. So you can click on the cluster name, and I think first was Setosa, second was Virginica, and third one is I don't really remember that. Okay, but idea is that you can rename it, and you can, let's say Setosa, and we will say second one maybe Virginica, and I'll just see what is the third one, versicolor. Maybe third one is versicolor. Okay, and with that I'm done. So that's how you can change the groups. So whenever you will get these groups over here, these names will be changed. the cluster names will be changed, and that will be more business friendly name as compared to simply cluster. Now after this, what you can do is you can further experiment, since there is no limitation, or it's simply based on how much you can really think, and you can combine with petal length and sepal length, or petal width and sepal width, and try to see whether you are getting more and more accuracy. The only thing is, I would suggest that do not even try to get 100% of accuracy. First of all, that's not possible. Even after a lot of manipulation, a lot of experiment, if you even get it, that will lead to one other problem in data science, which is called overfitting. That means you are overly manipulating, overly simplifying the data, which may work well when you have some seen data or you are aware about it, but on unseen data it will never gonna work. I would say not never, but most of the time it will not gonna work. Okay, so that's about cluster. What you can do is it is also very important that you identify that how many values it has calculated right and wrong. So what you can do is create a calculated field and basically say maybe accuracy. Yeah, that's what they say in data science, accuracy. And what it is basically species cluster is equals to species. Okay, and what I can do is I can create another sheet, and I will just say accuracy on the column. So it has false, but it should have shown us true as well. So let me quickly go back and check. Edit species cluster. Okay, equals to species, and okay. And what I'll do is just one quick check is I'll just create one sheet. I will say petal length, petal width. I will remove the aggregate measure. I'm sorry about that. Petal width. And then based on species, I'll put it on color. Setosa, versicolor, virginica. And that's our actual data. And here, if I go ahead and remove the cluster, or simply remove it over here and put it species cluster over here, and Setosa, virginica, versicolor, I'm just checking the ordering. So Setosa, versicolor, I think that's, we should have the same naming convention, otherwise since it is equals to, it is checking whether it is true or false. So in small case, Setosa, versicolor and virginica. And I will just go ahead in the cluster, edit the group, rename. So first one is Setosa, which is in small. Second one is virginica, and I need to check. I'll check once again. And versicolor, V-E-R-I-S-C-O-L. Okay. Setosa, virginica, versicolor. Setosa, okay. I just need to have versicolor as the second one. So that's, sometimes you may not get the correct output, and you need to really see whether values are properly mentioned over here. So I will name it to versicolor, otherwise you will get more false than right, and which is not right. Click OK, and let's see this. I'll just remove that. Edit species cluster equals to species. I will come here. Now we have true and false both, so that's good. And to basically get the count, what we need to do is bring another field over here, which is nothing but number of records. Okay, so we have 52 is false and 90 is true. Again, doesn't seem to me something which is absolutely correct. Maybe I'm just messing up with the, the naming over here. So if I go like VIR, right? So this will create an issue. What I'm doing is VER, I'm saying, however, it is VIR GINICA. VIR. So what I'll do is I'll go down and copy this so that I'm not messing up more with that. Edit group, come here and rename. No, not the one, this one, rename. So we are good over here. And then versicolor, I'll just check once more. I'll go up and VERSICOL. Yeah, I'm good over here. So I'll click OK. As soon as I click OK, let me see the count. So now you can see, now it is as per my expectation that only 6 incorrect values which it has classified or clustered wrong. However, true is 144. What we can do is create a bar chart. So with that, and it should have come bar chart. Okay, so with that you can see, or you can visualize, give the visualization back to your users about the accuracy part, how much is the accuracy. And third thing is you can combine all of this into a cool dashboard. So let's go ahead and create that to complete this entire information. So new dashboard, we are bringing the sheet 1, which is our so I will just remove 1. Alright, okay, so we'll give sheet 1 name as ML, which is machine learning cluster, real values and accuracy. Okay, and here I'm coming. So this is the ML cluster, clearly indicating this is the real value, and as you can see here, in case of this orange and this is red, so this is misclassification. After that we can produce a plot of accuracy as well, and we can see that we have more true number as compared to false. So there is a reason that you can trust our algorithm. So that's about it. But as I said, it's just one single way or one way of thinking about it. There are a number of ways by which you can think, and you can further improve it via dashboard or something. So that's the first video that I have. I will show you a couple of more examples in coming days related to clustering so that you will get a better idea and more data to play with. Hey guys, this is Abhishek, and in this video we will see how we can utilize the power of R for creation of linear regression. So you have already seen how you can create the linear regression, and now we will use R to create a linear regression. So let's go to R. So before I move ahead, quick information: if you are really interested in learning about linear regression, you can visit the website onlinecourse.science.psu.edu/stats501/node/250. So it has a very good definition of what the linear regression is and a lot of different topics, because it is a very wide subject and not thoroughly covered in this course, because my objective is to show you how you can execute it with the help of Tableau and R. But if you are really interested in learning the theory, that's where I see, or I prefer, with like whenever I have any doubt or I have to revisit something, I go here. Okay, so let's go to first of all R, and here I have already started the R service by first of all importing the library rserv and then executing the function rserv. Alright, so once we are there, then what we can do is we can come to Tableau, and in the Tableau we will import the Excel file. So I'll just click on the Excel and I'll go to my Tableau where my file is and import the sales. So once we import it, we'll drag the orders data over here, and it has some information like order ID, order date, order priority, quantity, sales, discount, ship mode, and a lot of different fields. So what I'll do is come back here in sheet. I have dimensions over here and measures over here. So the objective of this particular video is to identify the profit based on the sales and product based margin. So far you have seen that we have just used one single variable to identify the either predicted sales or profit in the previous video, but now we are extending and seeing the two different variables to predict one particular variable. So to revisit, we will going to predict the profit based on product based margin and sales. And let's connect our Tableau with R. So for that, go to Help, Setting and Performance, Manage External Service Connection. Once I click here, this should be your parameter, localhost, since we are running on local machine, and then the port should be 6311. Click on the test connection. You should get this message, successfully connected to the RServe service. Click OK and OK. After that, to write the algorithm or to write the function for the prediction, go to Analysis, create calculated field, and in that what we will going to write is the name of the calculated field as predicted profit, because profit is already present, and since we are predicting it, we will write predict profit. And then we will write script underscore real. So I will come down to this third, press tab and start the double quotation, press the enter, another enter, and we want to predict it based on the, so we want to predict the profit. So first of all, let me write the profit, sum of profit based on sum of sales and the product base margin. So these are the three fields. We want to predict profit based on sum of sales and product based margin. So what I will going to do to simplify and not make our script too much technical, I will take these parameters, sum of profit, sum of sales, sum of product based margin, into variables. So how I can do that? First of all, I will write x variable, x, and then this notation. This notation basically is an assignment notation within the R. Even you can use equal to, but mostly when you are an experienced R programmer or a regular R programmer, you tend to use this assignment operator. So it's good that you come into this habit. So assignment of arg1. So when I'm saying arg1, what happening is sum of profit is going into x, semicolon, then similarly y dot r2. Now sales is going into the sum of sales is going into the y, and then z as dot r3. Now the product sum of product base margin is going into the z. Now let's create the linear regression function. So for that, I will say linreg. I'm creating an object to store the output of the linear regression, and the method is lm, linear model, within the R. Open and close the parenthesis, and what we need to write is now x, because x is representing profit. So we will write x and then tilde sign to create the formula y plus z. So what is happening over here, we are specifying within the linear model function of R that we want to predict the profit x based on the sales. Sales is coming from here, which is argument 2, first, second. This is the argument 2, which is y, and then as well as based on the third argument, which is here in z, and represent the product based margin. Alright, once you are there, then what you need to do is just write the linreg to get the fitted value or the predicted fitted values based on this model. So it's a very simple script, as you can see, but initially it will give you a little tough time, but if you will follow this particular method of saving the argument into variable and then using that variable, your method or your expression will be less technical and more familiar and user-friendly for you as well as anyone who is reading that. So only thing you need to remember is that these are three different argument 1, argument 2, argument 3, and it's represented by dot notation .arg1, .arg2, .arg3, and by this way, using the assignment operator of R, you can assign the new variable so that it becomes little less technical when you are specifying into a linear model function or any other R related function. Okay, so let's click apply and OK to come back. Alright, so now what I want to do is let's say I want region over here on my rows, and then I want profit over here, and then I want predicted profit. Okay, so it will take a couple of seconds, and now I have profit and I have predicted profit. As you can see, somehow it is similar, but as you can see for Nunavut, it's comparatively high as compared to the original value, but that happens when you actually trying to predict. It's not always absolute value, because then it's a different issue altogether, but it should be near to the reality. So what I'll do is I will just make it on the same axis, and for that I will right click over here and say dual axis, so it will come on the same axis, both charts. Alright, so what happens here is it's on the dual axis, and I think it's pretty much in sync, but just to make sure it's sync, I will click on Synchronize Axis. Okay, and this is representing predicted profit, this is representing original profit. So here, in case of Atlantic, here is my actual profit, but what we predicted based on the sales and profit margin, it should be here, right? And but in case of West, what we are seeing that based on the sales and product price margin, your profit should be higher, but it is less. So this basically creates more questions about what it is really happening in such cases. Now, to better represent it, what I can do is I can take my profit, which is here, sum of profit, and change from automatic to bar chart so that I have a better representation. It will take again a couple of seconds, and now you can clearly see that the bar representing the actual profit, and these dot notation, these circles are representing the predicted profit. And in this case, in some cases, it's very close, like here. Even here, it's very close, Quebec, and yeah. But in a case of West or in case of Nunavut, it's pretty far. So that triggers more questions, as I mentioned, and you can investigate what's really happening over there. But this is a quick way by which you can use the predicted values on the chart and then, you know, to do your data analysis. The next piece I will show you a different way about how you can use that. So I'm creating a sheet 2, and what I'm doing is I'm writing the sum of profit over here, putting the profit over here, and predicted profit over here. And what I'm doing is I'm again taking the region over here, and it will take a couple of seconds to do all that calculation. And now, as you can see, the profit and predicted profits are coming on the X and Y axis, and here we have the different region, but it's not calculating properly because you are only getting the regions, but what you need is the values. So to present the values, what you can do is come over here, say compute using region, and now it will represent the values properly for the different regions. So after that, what we can do is we can put a regression line. So right click, trend line, show trend line, And once we show the trend line, you will see that it basically represent opposite in this case. So what I'll do is quickly I need to just change the and put sum of profit over here because it was taking it a bit opposite. Yeah, now it is good. So this line basically tells how well your fit line is as compared to your predicted values, the actual and predicted values, and if there is any relation. Alternatively, you can use other dimension to see how well this particular formula is fitting your values. So for example, you have product category, put it here on the column, and you will see the different line for furniture, office supplies, and technology for the profit calculation. So that's about it, how you can create and use the multiple dimensions to predict the values and see how well your model is working.